Good morning to everyone. I'm Dr. Sumi MS. The name of the course is Electric Circuit Analysis, and today's lecture topic is Resistors in Parallel Circuits. On completion, the students will be able to define a parallel circuit and obtain the values of circuit elements in a parallel circuit. In a parallel circuit, the sum of currents I1, I2, and I3 is equal to the total current I in the circuit. That is, I is equal to I1 plus I2 plus I3. And the source potential difference V volts is the same across each of the resistor. Hence, from Ohm's law, we shall write I1 is equal to V by R1, I2 is equal to V by R2, and I3 is equal to V by R3. And the total current in the network I is equal to V by R. Here I1, I2 and I3 are the current across the resistors R1, R2 and R3, where R1, R2 and R3 are in parallel, and R is the total circuit resistor. Since I is equal to I1 plus I2 plus I3, we shall write I as V by R, I1 as V by R1, I2 as V by R2 and I3 as V by R3. Therefore, V by R is equal to V by R1 plus V by R2 plus V by R3. Dividing the above equation throughout by V, we can get 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. This equation must be used when finding the total resistance R of a given parallel circuit. For a special case with two parallel resistors, we shall write the total resistance R is equal to R1 R2 divided by R1 plus R2. Problem 1. For the given circuit, determine the reading on the ammeter and the value of resistance R2. Solution. The potential difference across resistance R1 is the same as that supply voltage V, and hence the supply voltage V is equal to 8 into 5, which is 40 volts. And the reading on the ammeter I is equal to V by R3. Substituting V as 40 volts and R3 as 20, we are getting I is equal to 20 amperes. The current flowing through the resistance R2 is I1 minus 8 minus 2, which is equal to 1 amperes. And hence we shall now determine R2 as V by I2, that is V by 1, which is equal to 40 ohms. Problem 2. For the circuit shown in figure, find the value of the supply voltage V and the value of current I. Potential difference across the given 20 ohm resistance is equal to I2 into R2, that is 3 into 20, which is equal to 6 volt. Hence, we can get the supply voltage V equal to 6 volts. Since the circuit is connected in parallel, the current is distributed as I1, I2 and I3 across the resistors. And we shall write I1 is equal to V by R1, which is equal to 60 by 10, that is 6 amperes. And I2 is 3 amperes, and I3 is equal to V by R3, which is 60 by 60, that is 1 ampere. And the current I is given as I1 plus I2 plus I3, which is equal to 6 plus 3 plus 1, that is 10 ampere. Alternatively, we can find 1 by R is equal to 1 by 60 plus 1 by 20 plus 1 by 10, which is equal to 10 by 60. And hence, the resistance R is equal to 60 by 10, which is 6 ohms. And current I can be given as V by R, which is equal to 60 divided by 6, that is 10 amperes. Quiz questions on resistors in parallel circuits. Define a parallel circuit. Write down the general equation for finding the total resistance R of a parallel circuit. Thank you.